Hello everyone. So here we have a truth table and we are asked to create a circuit from this truth table. We have three inputs here, and since we have three inputs, 2 to the 3 equals to 8, we will have 8 different states. Out of these 8 different states that we have F as the output that we want out of this circuit. So out of these 8 outputs that we want, we have 3 true outputs. So as you can see here, we can highlight them and we are going to write the expressions for them. So the first thing that we are going to do is that we are going to write the sums of products for the most general equation expression for this table. So as you can see, we have 0, 1, 0. We want to have an expression where all of these are ones. So not A is going to turn this 0 into 1. We have B, and we have a not C, which is going to turn this into a 1. So the output can be 1. Not A, B, C for this first line. The second line is here. As you can see, we have 1, 0 here. We have a 0 here, and that's the only thing in this line that we are going to need to inverse, which means we are going to have an OR in between, and we are going to write the second expression. Not A, B, C is going to be our expression for the second line, and then we are going to have another OR to write the third and last expression. And as you can see, all of them are ones, so we are just going to write A, B, C here. Now that we have our general expression, we are going to need to simplify it. The first thing that I spot here is that for these two products here, we have not AB, not AB as the common term. So when we write not AB in parentheses, not C or C, we have not C or C in parentheses, and that's going to naturally give us 1. And that means we can eliminate that part. Therefore, we write not A and B, or the last part, last product here, or ABC. And when I look at these two products, I can directly spot that the common term is B. So I'm going to take out B and write the remaining of the expression in a parenthesis, not A or AC. Okay, perfect. Now I can distribute this not A over AC. When I do that, I get not A or A, which is 1. And then I have not A distributed over C, C. That means since I could eliminate not A or A, the only expression that I am left with is not A or C here. We had B in the outside, and this is our simplest expression that we can get from this circuit. How are we going to create the actual circuit for this? So I would very much prefer to start from the part that is in parentheses. So I have a not A here, and my input was A, so I need to inverse it. I'm going to inverse it with a NOT gate. And then this not A is going to be fed into an OR gate with C, and then their output needs to go into an AND gate with B. And therefore, I have my output F here. And this F corresponds directly to this truth table. Okay. Thank you very much.